Hey, problem solvers, Colfax Math here. Today I was going to go over probability, a quick introduction to probability, kind of some of the problems you might see on any standardized test or in an Algebra 2 pre-calc class. Probability is great for gambling, cards, dice, but more importantly, it has a lot of applications. It's the foundation for statistics, quantitative decision making in business. So understanding probability will really help you in a lot of other math classes as well. Never mind the fact that it's a really common standardized math type problem. Okay, let's get started with the definition of probability. So the probability of an event is defined as the number in the event over the number in the sample space. And what that means is you're just looking at the likelihood of an event happening. So let's say you have a coin, I have a penny right here. There is no such thing as a lucky penny. There's only two outcomes if I flip that coin, right? Either it comes up tails or it comes up heads. So the number in the sample space is tails or heads. So there are two outcomes. So what's the probability I throw a coin and I get heads? Well, a head would be a success, or the event of getting a heads out of the total number of outcomes, 2. So the probability of getting heads when I flip that coin is 1 out of 2. That kind of makes sense. And you should always go back to that definition if you're having trouble figuring out a probability problem. So let's turn it up a little bit to a 6-sided dice. Let's say this green die right here. What's the probability of getting a 3? Well, the probability would be the event getting a 3. There's only one of those. So the probability of getting a 3 would be the event getting a 3, one of those, out of the total number of outcomes, and there are 6 outcomes. Say rather than flip it once or twice, we now flip it 3 times. So I flip this coin 3 times. How many things could happen on the first flip? Well, 2 things could happen, either tail or heads. I flip it a second time. How many things could happen? 2. And then I flip it a third time. What are the 2 things that could happen, tails or heads? So I put that all together and I see 2 times 2, 4 times 2, 8. There are a total of 8 outcomes. So if I flip this coin 3 times, I could either get tails, 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 or tails, tails, heads, all the way down to heads, heads, heads. So let's say I flip that coin 3 times. What's the probability of getting tails, and then tails, and then tails? Well, and then means multiply each time. So probability of getting tails, 1/2, and then tails, 1/2, and then tails, 1/2. I multiply across the top to get 1, multiply across the bottom to get 8, and I can see it's 1/8. Or I could look at my sample space and see that there's only one outcome where all of them are tails. This kind of leads us to the conclusion that the word and always means to multiply, and the word or always means to add. So what is the probability that I get heads or tails? Well, that would be probably a heads 1/2, or add probably a tails 1/2. 1/2 plus 1/2 is 1. So that's a good way to remember and is multiply, or is add. And I think that's probably pretty good for coin tosses. You know, what's the probability of getting 2 tails? So what's the probability of getting 2 tails, say in 3 flips? Best way to do that one is to draw out the whole sample space and see that you have 2 tails here, 2 tails here, here, and that's it. So it's either this one or this one or this one. So 1/8 plus 1/8 plus 1/8 would be 3/8. All right, let's go back to the dice and get a little more complicated with the dice. Let's take a look at 2 dice. Let's say a green one and a white one. What's the probability of rolling this 1 dice and getting a 6? We said that, well, that's going to be 1 out of 6 because there's the event getting a 6 out of the total number of sides, 6. However, let's do that instead of doing it in a series, like rolling it twice. What's the probability of getting a 3 and then a 4? Let's just put 2 dice in the mix. So I take these 2 dice, I roll them. What's the probability of getting an 11? Well, the best way to do that is to draw out the whole sample space, which I did right here. And that sample space in green is a green die, in purple is a white die. So what's the probability of getting 11? Well, I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, so forth. And I can see I have 36 outcomes. So how many of those are the dice add up to 11? Well, it's this one and this one, right? 5 and a 6 equals 11, and 6 and a 5 equal 11. So the probability I throw 2 dice and get an 11 is only going to be 2 out of the whole sample space of 36 possible outcomes. Or I could reduce that to 1 out of 18. What's the probability I take 2 dice and I throw them and I get a 7? Well, pretty unlikely to get 11 twice in a row. So what's the probability I get a 7? Well, I got to figure out how many 7s are, and there are a lot of ways to get a 7. I get a 1 and a 6, a 2 and a 5, 3 and a 4, 4 and a 3, and so forth. So there's 1, 2, 3, 4, 5, 6. 6 ways to get a 7. So the probability of getting a 7 is 6 out of 36, or I could reduce that to 1/6. All probabilities, so probability of all events, are always greater than or equal to 0 and less than or equal to 1. So all probabilities have to sit in that window. And again, to recap, the word and always means to multiply. The word or always means to add. If instead I had 2 8-sided dice like these fractional dice that have 8 faces on there, and I want to know what's the probability of getting a certain outcome here, well, now my square is not 6 by 6, but say 8 by 8. Another place you see a lot of probability is with cards. So with a deck of cards, there's 4 suits. Most people assume the jokers are removed out of the cards. So you need to know that there are 4 suits of 13 cards to give you a total of 52 cards. So there's 13 diamonds, and the diamonds are red, hearts are red, clubs are black, and then the 4 suit spades. I might find a spade. So what's the probability of drawing 1 card at random out of this deck and it being a diamond? So what's the probability of a diamond? Well, we know there are 13 diamonds out of 52, or there's 1 and 4. So the probability of drawing a diamond would be 13 out of 52, or reduced to 1 and 4. What's the probability of pulling a jack of spades? Probability of pulling the jack of spades. Well, there's only 1 card that's the jack of spades, so that's 1 out of 52. What's the probability of pulling a jack? Well, how many jacks are there? There are 4 out of a total of 52. That's going to reduce to 1/13. Another piece of probability that you might come into contact with as well is this idea with replacement or without replacement. So let's say I pull this jack out of the deck in one sample. Now I only have 51 cards left. What's the probability of pulling a jack out of this deck? So that's without replacement. The probability of pulling a jack out of that deck is going to be the number of jacks that are in there, 3 out of the total number of cards, 51. And I think you could reduce that to 17, 1 out of 17. So probability is very useful. It really helps you make better decisions if you know the likelihood of an outcome. Usually in class it's taught with dice or cards, those kinds of things. But there are really a lot of applications for how much you pay in insurance, whether or not you want to insure, whether or not you want to make business decisions based on the likelihood of the event. And that kind of leads to expected value, where you take a cost or a benefit and multiply by the likelihood. But I'll put that off for another video. Math is everywhere. This channel is Colfax Math. If you're new to it, think about subscribing, and please comment below about where you've used probability, whether it's in class or on a test or a standardized test. Okay, thank you for watching.